Welcome to our video tutorial on data movement instructions of the 8086 microprocessor. In this video, we'll explore the hardware specification of the 8086 microprocessor. Let's start. The 8086 microprocessor is available in different clock rates and packaged in a 40-pin configuration. The 8086 operates in single processor or multiprocessor configuration to achieve high performance. The pins serve a particular function in minimum mode, single processor mode, and other function in maximum mode configuration, multiprocessor mode. The 8086 signals can be categorized in three groups. The first are the signal having common functions in minimum as well as maximum mode. The second are the signals which have special functions for minimum mode. The third are the signals having special functions for maximum mode. Now let's see pins that serve in common mode, minimum and maximum mode. AD0 AD15, bidirectional. Address/data bus. Low order address bus, these are multiplexed with data. When AD lines are used to transmit memory address, the symbol A is used instead of AD, for example A0 A15. When data are transmitted over AD lines, the symbol D is used in place of AD, for example D0 D7, D8 D15, or D0 D15, A16/S3, A17/S4, A18/S5, A19/S6. High order address bus. These are multiplexed with status signals. Bus high enable/status output signal. It is used to enable data onto the most significant half of data bus, D8 D15. 8-bit device connected to upper half of the data bus use BHE, active low, signal. It is multiplexed with status signal S7. Minimum/maximum. This pin signal indicates what mode the processor is to operate in. RD, read, active low. The signal is used for read operation. It is an output signal. It is active when low. Input is tested by the wait instruction. 8086 will enter a wait state after execution of the wait instruction and will resume execution only when the is made low by an active hardware. This is used to synchronize an external activity to the processor internal operation. Ready. This is the acknowledgement from the slow device or memory that they have completed the data transfer. The signal made available by the devices is synchronized by the 8284A clock generator to provide ready input to the 8086. The signal is active high. Reset, input. Causes the processor to immediately terminate its present activity. The signal must be active high for at least 4 clock cycles. CLK. The clock input provides the basic timing for processor operation and bus control activity. It's an asymmetric square wave with 33% duty cycle. INTR interrupt request. This is a triggered input. This is sampled during the last clock cycles of each instruction to determine the availability of the request. If any interrupt request is pending, the processor enters the interrupt acknowledge cycle. This signal is active high and internally synchronized. GND, ground, used to dissipate the accumulated heat. VCC, power supply, used to provide positive 5 voltage. Minimum mode. In the minimum mode of operation, the microprocessor do not associate with any coprocessors and cannot be used for multiprocessor systems. When this pin is high, 8086 operates in minimum mode. Pins 24 to 31. Data transmit/receive, output signal from the processor to control the direction of data flow through the data transceivers. Data enable, output signal from the processor used as output enable for the transceivers. Address latch enable, used to demultiplex the address and data lines using external latches. Used to differentiate memory access and I/O access. For memory reference instructions, it is high. For in and out instructions, it is low. Write control signal, asserted low whenever processor writes data to memory or I/O port. Interrupt acknowledge, when the interrupt request is accepted by the processor, the output is low on this line. Hold input signal to the processor form the bus masters as a request to grant the control of the bus. Usually used by the DMA controller to get the control of the bus. Hold acknowledge signal by the processor to the busmaster requesting the control of the bus through hold. The acknowledge is asserted high when the processor accepts hold. Maximum mode. In the maximum mode, the 8086 can work in multiprocessor or coprocessor configuration. When this pin is low, 8086 operates in maximum mode. During maximum mode operation, the MN/ is grounded, logic low. Pins 24 to 31 are reassigned. S0, S1, S2 status signals, used by the 8086 bus controller to generate bus timing and control signals. These are decoded as shown in the fig above. QS0, QS1, Q status, the processor provides the status of Q in these lines. The Q status can be used by external device to track the internal status of the Q in 8086. The output on QS0 and QS1 can be interpreted as shown in the above. Bus request/bus grant, these requests are used by other local bus masters to force the processor to release the local bus at the end of the processor's current bus cycle. These pins are bidirectional. The request on _ will have higher priority than _. Lock and output signal activated by the lock prefix instruction remains active until the completion of the instruction prefixed by lock. The 8086 output low on the G pin while executing an instruction prefixed by lock to prevent other bus masters from gaining control of the system bus. Thank you for watching our video tutorial on data movement instructions of the 8086 microprocessor. We hope you found it informative and helpful. Stay tuned for more tutorials on microprocessor and assembly language programming.